Hello my dear friends, welcome to ASP Max and Dynamic YouTube channel. I am Sebastian. Today I explain the concept about the Fourier series. Let me come to Fourier series. The Fourier series for the function f of x in the interval c less than x less than c plus 2 phi is given by f of x is equal to a naught divided by 2 plus summation n equal to 1 to infinity a n cos nx plus summation n equal to 1 to infinity pn sin nx. So this is the Fourier series for this interval. So c less than x less than c plus 2 phi, if they given means you have to write the formula of the Fourier series means a naught a n b n. So a naught separate, but a n with cos nx, pn with sin nx, it is important. Right now the a naught, what is the value, a n what is the value, pn what is the value for this interval. The interval only changes in the Fourier series. Here a naught is equal to 1 over pi integral c to c plus pi, c plus 2 phi for this the interval. So f of x dx, this is the a naught value. A n is equal to 1 over pi integral c to c plus 2 phi, because this is a given phi. Given the interval f of x cos nx dx, pn is equal to 1 over pi integral c to c plus 2 pi f of x sin nx dx. Here the a naught a n b n is Euler formula, otherwise Euler coefficient we can call. Another, the interval is changed. When you substitute the c is equal to 0, you can get the interval like this: 0 less than x less than 2 pi. So at the same time f of x is equal to a naught divided by 2 plus summation n equal to 1 to infinity a n cos nx plus summation n equal to 1 to infinity pn sin nx. This is the common for all the intervals, but the coefficients, Euler coefficients only changes. So you see here the interval 0 to 2 pi, here also you have to change the interval 1 over pi integral 0 to 2 pi f of x dx, a n equal to 1 over pi 0 to 2 pi f of x cos nx dx, pn is equal to 1 over pi 0 to 2 pi integral 0 to 2 pi f of x sin nx dx. So once the interval changes means in the coefficients you have to change the intervals, and in the interval in the limits. This is very important in the Fourier series. Another one, c is equal to negative pi. If you substitute in the interval, you can get the different interval, negative pi to and less than x less than pi, negative pi to pi. So the formula is same for all the interval, but in the coefficients, Euler coefficients or Euler formula entirely different. What the difference means, in the interval the limits negative pi to pi, negative pi to pi, negative pi to pi, but the functions and the cos nx, once a n means it is default cos nx dx. This is f of x cos nx dx. This is a given function, so you have to add the cos n, not add, you multiply with the cos nx. In the pn means the given the function with the sin nx. This is the standard one for this. According to the limit, you have to write the formula Fourier series like this. Then it is important result for the general c to integral c to c plus 2 pi cos nx dx means it is 0. It is a standard result. N does not equal to 0. N equal to 0 means the value is 1, but here n does not equal to 0 means next value means for this limit value you can get the 0. So once if you see any steps in the problem, immediately you can substitute the 0. So sin nx the same 0, but c integral c to c plus 2 pi cos mx cos nx. You see here cos function, but in the variable m, but here n means it is 0 when m does not equal to n. But when you get it the value means cos square nx only values. What is the value? It is a pi. N does not equal to 0. The same in here also, sin mx cos nx. Here the function different, but it is 0 when m does not equal to n. Here sin nx cos nx. Here you see the functions and different, but here n, it is 0. The sine function same, but the variables are different, m and n. So here it is a 0. Sine squared nx dx equal to pi. The standard result you have to keep in your mind. When you need, you can apply direct. Even function and odd function. When you can call the function is even, means you have to check the function f of negative. You have to substitute, instead of x is equal to negative x, you want to get the f of x. If you get it, means the function is even function. Example, x squared cos x sin squared x modulus x in the sin x. These are all even function. And also the function is add function, means when once if you substitute the x instead of minus x, you can get it minus f of x, means the function is add function. Sorry, here it is add function. So it is x squared sin x tan for 3x or add function. So here also, if you know very well, means you see in the interval negative pi to pi f of x dx, once the function is equal to 0, means if f of x is an add function. The particular place, for example, x power 3 dx, means immediately you can put it 0, because x power 3 is the add function. So once f of x is x squared, means you can write it like this: 2 into 0 to pi f of x dx, means the function is even function. The interval negative pi to pi, the limits interval or limits negative pi to pi, but here negative L to L, but both are same. The function is add function, but here, so the two steps is limit of negative pi to pi, the two steps limit of negative L to L. This is only changes. The f of x is even function, means how we can write the Euler coefficients. For example, even function means it will appear a0 value and an value, but pn always 0. So here an is equal to a0 is equal to 1 over pi integral negative pi to pi f of x dx, means so in this value it will become 2 over pi 0 to pi f of x dx. And also an equal to 1 over pi negative pi to pi f of x cos nx dx, means 2 over pi integral 0 to pi f of x cos nx dx. Likewise you have to write it. Once if you see the f of x is even function, means you have to write a0 an, and you use this values, you substitute the even function instead of f of x, you find the value of a0 an, then you write it in the Euler formula. You substitute the a0, you substitute the an, then it is a f of x. F of x means the given function. So at the same time, here once a0 equal to this is the value, an is equal to this is the value, I wrote it. Once the f of x is add function, means the a0 here it is a wrong one, only summation n equal to 1 to pn sin x. Here a0 is not up here. The f of x equal to summation n equal to 1 to infinity pn sin nx. Pn is equal to 1 over pi integral negative pi to pi f of x sin nx dx is equal to 2 over pi integral 0 to pi f of x sin nx dx, like this. This is only it will appear for the add function. a0 and an is equal to always 0. So the a0 is equal to 0. Only f of x equal to summation n equal to 1 to infinity pn sin nx only it will come.